In this video, I'm going to introduce you to the force exerted by a stretched spring. The main idea in this video is something that has to be demonstrated by an experiment, and because of that, I have posted a separate video which shows that experiment, and I would encourage you to watch that as well. However, I've done my best to keep this video self-contained. So here's the idea. I have a ceiling here, and one end of a spring has been attached to a ceiling, and you can see that the spring is just hanging from the ceiling. And right now, nothing is pulling on that lower end of the spring, so we're just going to say that the spring is at its resting length, and I'm going to call that resting length capital L. Now we imagine that something like a hand comes in and grabs on that bottom end of the spring and pulls down. And when the hand is pulling down on that bottom end of the spring stretches by an amount delta L. Now, right now, we have that the hand and the spring are exerting forces on each other. The hand is pulling downward on the spring, so I have here a force F hand on spring. The spring is pulling upward on the hand, so I have here a force F spring on hand. According to Newton's third law of motion, the forces that the spring and the hand exert on each other are equally strong, so I'm using the same notation, F sub S, to indicate the strength of either force. What I show in the other video is that these forces that the hand and the spring exert on each other increase with the stretching of the spring. So in other words, the more the spring stretches, the stronger the forces that the hand and the spring are exerting on each other. And in fact, it turns out that the strength of these forces is directly proportional to the stretching of the spring. The way I can say that mathematically is I can say that the strength of these forces, F sub S, is proportional to the stretching of the spring, delta L, and this symbol here means proportional to. As we've seen before in this class, what this means is that if the quantity on one side doubles, the quantity on the other side doubles. If the quantity on one side triples, the quantity on the other side triples. So I demonstrated this proportionality in the experiment in the other video. Anyways, we don't really like to have proportionalities floating around. We would rather have an equation. And the way we go from a proportionality to an equation is to introduce a proportionality constant. So here I'm going to write that same idea, except as an equation with a proportionality constant. I now have Fs, the strength of the spring forces, is equal to a proportionality constant denoted lowercase k, then multiplied by the stretching of the spring. Now, what does this proportionality constant actually mean? Well, notice that if you have a big value of k, that means you're going to have a large spring force for one particular stretching of the spring. If you have a small value of k, then you're going to have a small spring force for one particular stretching of the spring. So basically, bigger k corresponds to a stiffer spring, or in other words, bigger k corresponds to a spring which is more difficult to stretch. The name we give to this k is either spring constant or Hooke's constant. This statement is what's known as Hooke's law. There's one more point I wanted to make before we finish the video, which is that Hooke's law can also be applied to a spring which is being compressed. So in this lower figure here, I have a spring at its resting length. Here it's horizontal instead of vertical, but same ideas apply. This is a spring at its resting length. And here you can see that a hand has come in and compressed the spring through a distance delta L. So what we have here is that the hand is exerting a force on the spring compressing it. This is the force hand on spring here. And by Newton's third law, the spring is now exerting a force on the hand, pushing it back the other way. So this is the force spring on hand here. And also by Newton's third law, those forces are equally strong. So I have used that same notation, again, F sub S, to describe the strengths of the forces that the hand and spring exert on each other. So what is the strength of those forces? Well, we can say that the strength of either force is equal to K, which is the spring constant for the spring, multiplied by delta L, which is here the compression of the spring. And I want to emphasize that for each spring, there is a unique value of K associated with that spring that we would use to describe both compression and extension. Okay, so now I have introduced you to the spring force and how we use Hooke's law to calculate the forces exerted by stretched or compressed springs. And in the next video, we're going to use Hooke's law to do an example involving actually two different springs.